record. Welcome to virtual students. This is fourth period. Here's a warm-up. We don't do this every day, but we do it when we get more consistent. We'll be doing it more consistent, and we're here. I know I wasn't here yesterday, but glad to be back. Get to see all of you, even you, Zodi. Hey, please solve for X. Those three problems. You just do them right at your seats.
Warm in here?
A little bit, maybe. Oh, and you got them done yet?
Yeah.
Okay, let's take a look. Hopefully you guys got them all done. Well, whenever the variable's in the numerator, look at this. You have to multiply both sides by 6. Can you see that above the calculator there? Multiply both sides by 6. Whatever I do to one side, I got to do to the other side. 6 times 12, then we get x equals 72. Does that make sense? We're good, good, good. Okay, number 2. What about when x is in the denominator? We got to get the x out of the denominator by multiplying both sides by x. And then we have 15 times x. That's called the coefficient. Ooh, there's a good word. Coefficient. 15. X equals 45. Then we divide by 15. And x then is equal to 3. And number 3, the easiest one of all 3. We just reduce the fraction. 15 divided by 5, and we get 3 again. Who got all 3 right? Raise your hands. Nice and proud. If you didn't get all 3 right, do you see what you didn't?
Yeah. I was doing tangent.
We're not doing the trig functions yet, Nicholas, but that is actually why I'm showing you. As you can see over here, we will have a problem like this later today. The tangent of 50 is equal to x over 15. What do? Multiply by 15. Okay, so that's why I did that warm-up, to help prep you for some problems we're going to be solving later. Got it? There's a method to the madness, Chase. I know you may not believe it. All right, let's take a look at some notes. 13:2. Let's label it the sine. That's how you spell it correctly. Cosine ratios. The sine and cosine ratios. Move it to the top of the screen. Virtual students, it'd be good to write this down. Okay, so let's create a triangle. Make it nice and large. It's a right triangle, so put a right angle in it right there. We're going to go angle A, angle B, and angle C. All right, now, in this section, we have only two, but overall now we have three trig functions. Yeah, the word trig. What's that short for? Mr. Ring. Don't look. No cheating. Spell it. Very good. Very good. Mr. Freeze, spell hypotenuse. Don't be looking. No. Abbott, try it. No. Zodi. US what? USE, that is correct. Zodi. In the closet over there. Open it up. And there's a canister that's got some mints. Get one for you and Mr. Ring. And tease Mr. Freeze as you walk by because he did not earn one. Oh, I wish I was the one doing the teasing. I'd hold it right in front of his nose. Right? Hey, you got to walk it right in front of Abbott, too, because he didn't get one either. Right in front. Yeah, there you go. Oh, the old pull away. I love it. Yes. Yes, yes, yes. Okay, so three trig functions. All right, so now sine, cosine. Sine is the opposite leg over the hypotenuse. Make sure you're writing this down. The cosine ratio is the adjacent leg over the hypotenuse. Okay, so you guys ever watch Wheel of Fortune?
Oh, yeah.
You guys know that game show, Wheel of Fortune? Vanna White, you know, she used to have to spin the letters, you know, because they were like on a rotating thing. Now she just kind of, you know, waves at it, right? Lance is going to be our Vanna White today. Just Lance. Here. Lance, stand up, please. Vanna. You see the wonderful flag behind you? Go ahead and point at it. It's the W flag. It's for the Cubs when they win a game. The best team in Major League Baseball. We can debate that later. So, if you don't mind, pull back the flag so that poster behind it is easy for everyone to see. Don't stand in front of it, Vanna. Everyone, don't stand over there. People can't see it. See, I know it's a hard job, isn't it? All right, so now point at the S for sine in the poster. Yes. See how it's highlighted in white. Okay, and sine on the right equals O over H. You're not doing a very good job, Lance. Yeah, you got to give it a little more flair. Yes, you got to. There. That's not bad. Lance, go to the C. Where's the C? Yes, and then it's equal to A over H. Yes, they're much better. I like that right there. Tangent, where's the T? No, T, there you go. And then the tangent is O over A. Yes. Okay, so what? Thank you, Lance Vanna. Okay, so why are we spending time? Because look at this. Yeah, I wrote it on the front board already, as you can see. For those of you looking at the screen, SOHCAHTOA. SOHCAHTOA. You guys say it out loud. SOHCAHTOA. It could be a song. Say it fast. SOHCAHTOA. 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 Kind of like you are soaking your toe. That's not even a dad joke. I mean, I'm bad at dad jokes. That's not even a dad joke. That's just a geometry joke. SOHCAHTOA. All right, Nicholas? Okay, so let's memorize it, though. What does it mean? SOHCAHTOA. Sine. Follow my pen as I follow along. Sine. Opposite. I'm going to add a word. It's not part of the acronym. I'm going to use the word over to represent the fraction. Okay, let me start again. Sine, opposite, over, hypotenuse. Cosine, adjacent, over, hypotenuse. Tangent, opposite, over, adjacent. Okay, now this isn't weird. This is actually a way to memorize. I'm going to ask you to close your eyes. I'm not making funny faces at you. Close your eyes. Close your eyes. Now, repeat after me. Sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Tangent, opposite, adjacent. Okay, open your eyes. Now, what we just did there, guys, it's called brain-friendly exercise. You should do that on your own when you're trying to memorize stuff. You can put it on a little index card. And you can read it. Then you can close your eyes and repeat it. It helps you memorize things. Your mind works that it pictures what your eyes just saw. So like if you close your eyes now, you could actually see this. Or you can see it where it's written on the board. Like when it comes quiz time, you'll be envisioning where it's written on the board or where it's written on the screen. And that I used blue ink. Write it. It's called brain-friendly memorization activities, and that's one of them, what we just did with you. Now, if you want to memorize it forever, in about inside of 24 hours, do what we just did, but do it for like 5 minutes. Just do it over and over and over and over again, and you'll never forget it. Okay? Now, just future reference to be the best student you can be. SOHCAHTOA. Sine, let's write all these out. Sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Tangent, opposite, adjacent. There are actually 6 trig functions. We're only going to deal with 3 of them. The sine, cosine, and tangent. Okay. Another trick to memorizing these or to recalling these, okay? The abbreviation for sine is sin. Okay, without getting into a deep theological, discussion, let's just agree that sin is bad. We want to get away from sin. Sin is way over there, and we're way over here. Right? It's like this. If this is the line of sin, like this is righteous behavior, and this is bad behavior, sin, right? Why is it that we want to see how close we can get? Oh, I didn't cross over the line. Oh, why don't we go as far? Okay, that's another discussion for another time. Freeze. But sin, can we all agree we want it away from us? Or it's on the opposite side. Right? Opposite. Sin, opposite over hypotenuse. Okay? So that's one way to think of it. Sin, sine. Cosine. abbreviated COS. What's the prefix? Co. Well, one way that we utilize the prefix of co is like a co-partner, or we cohabitate, or a co-op. And these are all people that are next to you. They're adjacent. Okay? So that's a secondary way to recall what sine and cosine, how you can keep them straight. Sin is yuck, get away from it. It's on the opposite side. Okay? Co means adjacent, it's next to. Does that make sense, Corbin? You're sin, I'm righteous behavior. I'm just saying, because you're on the opposite side of the room, and I'm on the adjacent side of it. I mean, on this side of the room. That makes sense. I'm teasing. I could be sin, and you could be there. You get the idea. We're on opposite sides. Okay, does that make sense? Okay. All right. So now let's come to the triangle here. Sine. All right. How can we apply this? Well, it all depends on which angle that we're talking about. So if we're talking about, let's say, angle B. Okay. So look at angle B, and that's what we're talking about right here. Well, once we declare an angle, now we can name all the sides. Well, side AB is always called the hypotenuse. It's always called the hypotenuse because it is opposite the 90-degree angle. And then opposite B, way over there, is side AC. So the opposite leg is AC. Does that make sense? Okay, and then B would be the adjacent leg. Because we're dealing with angle B, and so side BC is the adjacent leg. Okay, now what if we deal with angle A? Now notice I'm using a different color. Okay, so angle A, what's this side called still? It's still called the hypotenuse. So I'm just going to underline it. It's still the hypotenuse. It doesn't change. What's the other side called? That's called the opposite. So when I'm dealing with A, B, C, it was the adjacent side, but now it's the opposite side because it changed depending on the angle. Angle A, if I'm dealing with angle A, then AC is called the adjacent leg. So do you see how it can change depending on which angle you're talking about? Okay, so what's that look like? All right, so the sine of A is BC over AB. Look at that carefully. The sine of A, here's angle A, is opposite, get away from it, sine, sin, ugh. Get away from it, sine, BC over the hypotenuse, AB. Okay. What about the cosine of A? Well, that would be AC over AB. Now, we're not doing tangent today because we've already done that. But we could easily do it. Opposite over adjacent. Okay, any questions? Sine, cosine. Okay, let's that does it for the notes. Let's do a couple problems. All right. So open in your book to page 704. Let's see how this looks in a couple problems. And these are actually problems directly from your homework. Okay, so make sure you do them with me, and you're going to get a couple problems completed. Let's start with number 12. All right, the picture looks like this. There's the right angle. We have P, and that's 24 degrees. We have 19 here. R and Q. And then you have X. Okay, so now you got to have a little discussion going on in your head. You know, I've not really made a big point of this but it's really true in geometry, especially. You got this inner talk going on, right? And I want to help guide that inner talk. In your mind, you have to look at what's given and what can I conclude from it. Almost like we used to ask ourselves with a proof, remember? All right, but what's given? Well, they've given us angle P. So I want to consider what else is given. Well, don't they give us an opposite side to angle P? And then they've given us the hypotenuse. And so the question in your mind is, which trig function uses or utilizes opposite and hypotenuse? We got 3 to choose from: sine, cosine, tangent. Which trig function uses opposite and hypotenuse? Sine. So that's the trig function that we're going to set up. So we're going to go sine. We're going to abbreviate sine and use the word sin, but we still pronounce it sine. Sine of 24 degrees is equal to 19, which is the opposite, over the hypotenuse. Does everyone see how I generated that equation? I just basically, from what was given in the problem, and I have this inner dialogue going on in my head, which trig function do I need to use? Well, it depends. Since they've given us the opposite side and the hypotenuse, I'm going to use sine. Everyone got it? Now we solve. So we're going to multiply by x and divide by sine. So we end up with x is equal to 19 over the sine of 24. Now, I went through that pretty quickly, but if you remember, we did it already. Remember in our warm-up? When x is in the denominator, how do we solve? Okay. So we follow that math. So we end up with x equals sine over, let's get our calculator out. No glare, no glare, no glare, no glare. Okay, we're good. We're going to go 19 divided by the sine of 24. Did they tell us to round it to any decimal or anything? Good. So x then is approximate, since we're rounding. X is approximately 46.7. The length of the hypotenuse. Maybe feet or inches. I don't think they have a units, but 46.7. Amira, questions? You got it? Okay. Now I'm going to show you something that the book doesn't ask for. This is to aid in your further understanding. This is free stuff. Free. I'm not charging you anything for this. If this is 24 degrees, what's the measure of angle Q? 66. Come on, math majors. We subtract it from 90 degrees, right? So if that's 66, look at this. I can set up the cosine of 66 is equal to 19 over x. You see how I've now switched from using the sine function to the cosine function? All right. Solve, and I end up with x is equal to 19 over the cosine of 66. Let me use my outstanding calculator. Clear, clear, clear. 19 divided by the cosine of 66. Look at that. Look at that. X is still equal to 46.7. Does everyone see what happened? Same. Because they are called co-functions. They are complements of each other. Watch this. You everyone got your calculator? Either calculator or phone, don't care. You ready? Plug this in. Go the sine of 72. Don't tell me the decimal. Just look at it. Everyone got sine of 72? Now go the cosine of 18. Same number. Try it again. Let's do another one. Maybe it's just a freak and it just happened to happen. No, that's not true. Sine of 63. Cosine of 27. Essentially, since they are complements of each other, whatever number I go here, let's say sine of x, the equivalent cosine is 90 minus x. Ravens, that makes sense. See how they're always the same. Questions? Got one more problem to do. Let's go to number 16. Bottom of the page. Number 16. I'll get this right in the corner of the screen. Mira. Yes! Look at that. Hey, repeat after me. Sokotoa. Sokotoa. Okay, so last year I did a little thing with one of my favorite classes that whenever you said ka, C-A-H, ka, right? You had to raise your left hand. Ready? Sokotoa. Now we're putting some actions in there. Sokotoa. Your left hand, Sokotoa. Don't raise it when you do the so, only the ka. Sokotoa. Okay, so now when you do the so, you raise your right hand. Now your right hand can't be raised when you do your left hand. Okay, you ready? Sokotoa. Ready? Sokotoa. All right, so now when you put down your right hand, let's hear it. Ready? And then your left hand too. Sokotoa. A little louder, you got to say it louder. Sokotoa. This is all things to help you remember. Sokotoa. 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 Number 16. Let's look at it. Whoever thought geometry could be so much fun? I know. I'm probably the only one that thinks it's fun. But we got V, we got U, we got W, we have 11, we have 15. Recreating the picture. On number 16, they want us to find the measure. That's what the little m means out in front. The measure of angle W. Okay, so, well, again, we got this inner dialogue going on. What do we have? Well, I'm going to go ahead and throw in the x with the degree measure right there, because that's my unknown. That's what I'm trying to find. Okay, and so when I look at this angle, they've given me this side, and they've given me this side. What are those sides called? To me, they're called the adjacent and the hypotenuse. So which one uses the adjacent and the hypotenuse? The cosine. So the cosine of angle W is equal to adjacent over hypotenuse, which is 11 over 15. Okay, so let me rewrite that. The cosine of W is 11 over 15. Whenever we're finding the measure of an angle, a quick reminder, we always want to use the inverse function on our calculator. Whenever we're finding the measure of an angle, we always want to use the inverse function on our calculator. What's that look like? Well, then it would look like this. The cosine, -1, 11 over 15. Remember that? We did it for tangent, but it's still true for sine and cosine. So nothing changes for sine and cosine. All right, let's get the calculator going. Let's find it. Clear, clear, clear. No glare. We are looking good. Inverse cosine. So remember, if you're using your phone, sequences will be different. So make sure you're careful with that. Second cosine of 11 over 15 equals, there is our degree measure. Do they tell us to round it? Okay, so the measure of angle W to the nearest degree, this looks to me like 43 degrees. And it's approximate since we're rounding. Any questions? Okay, before I turn you loose and give you the assignment, one additional piece of info. Could we find the measure of VU? Could we find this? Yeah. We could use Pythagorean theorem. But it's not going to be a perfect root because it's not a Pythagorean triple. So just stay with the cosine one to solve. All right, here's our assignment. It starts on page 703, and we go 3 through 16. Do not submit. Not yet. We're going to add to it tomorrow. A couple reminders. Whenever you do homework, you need to label. When you label, what's that look like? Name, assignment, class period. And I don't mind if you add in there the date. Okay. Any questions? I'm going to turn the video off. Virtual students, 3 through 16. Virtual students, any questions, send me an email.